Hey everyone, welcome back, ready to dive in. Today, we're tackling a giant, no pun intended, Albert Einstein.
Huh.
We all know the name, we've all heard MCR,
Right.
but honestly, how many of us can really say we get Einstein? So that's our deep dive, going past the surface to understand why he matters, even a century later. And we're using Albert Einstein, A Relativistic Revolution, as our guide.
Great text. And it's not just the theories, it's how he thought, which is almost more important for us today, I think.
Totally agree. Because you can find equations anywhere, but what sparked those insights, that's what's fascinating. Like, the book talks about his school days, and he wasn't exactly teacher's pet, was he?
Not really, no. Clashed with authority, questioned everything. Some teachers even considered him lazy, imagine that. But it wasn't laziness, the text makes that clear. It was this burning curiosity. Rules, the way things were, didn't satisfy him. He had to know the why.
Which is funny because that's how a lot of us feel when we're first getting into science, right? You're like, wait, but why though? But most of us grow out of that. Einstein didn't.
Exactly. It stuck with him, and it's what allowed him to revolutionize physics. See, back then, Newtonian physics was king. It explained the world, everyone accepted it as the truth. But Einstein, he dared to question it. And that questioning led to special relativity.
Okay, special relativity, 1905. Time to warp our minds a bit. So basic, no, like really basic. What are we talking about here? Because I read this stuff and my brain starts doing backflips.
I hear you. Okay, so the core idea is this. Time and space, which we always thought of as separate, absolute things, they're not. They're connected, interwoven like a fabric. And this fabric, it could be warped and stretched.
Okay. So how does that change things?
Well, for one, your experience of time isn't constant. It's relative to your motion through space. The faster you move through space, the slower time passes for you relative to someone who's stationary.
Wait, seriously, so if I hop in a spaceship and blast off at, like, light speed...
Close to the speed of light, yeah.
Right, so I'm zooming around, and then I come back, and what? Time on Earth has moved way faster.
Exactly. That's the twin paradox. One twin stays on Earth, the other travels at near light speed. When they reunite, the traveling twin is actually younger, because time itself passed slower for them during their high-speed journey.
That is so trippy. Like, my brain just went through a black hole. Okay, so time is relative. But it gets even weirder, right? Because then Einstein decided to tackle gravity with general relativity in 1915.
Right, because special relativity was just the beginning. General relativity is even more mind-blowing. It basically says that gravity isn't a force acting between objects, as Newton thought. It's actually a curvature in that fabric of space-time caused by the objects themselves.
Okay, so it's not about objects pulling on each other. It's about them actually warping the space around them.
Precisely. Imagine a bowling ball on a trampoline. It creates a dip, right?
Right.
That's kind of like what a massive object does to space-time. It creates a curvature. And other objects like planets, they're just following the curves of that warped space-time, which is what we experience as gravity.
Wow. Okay. And light itself gets bent too, right? Like, because space-time is curved, light follows those curves.
Exactly. It was one of the predictions of general relativity. Light from distant stars, as it passes by the sun, would be slightly bent by the sun's gravity. And you know what? They actually observed it during a solar eclipse in 1919.
I remember reading about that. Yeah. Mind-blowing. So we have this theory, 100 years old, predicting stuff we're only able to confirm much later.
It's incredible. And it's not just some abstract thing. General relativity is the reason GPS works. The satellites, they're moving fast. Time is slightly slower for them. We have to account for that to pinpoint locations accurately on Earth.
That's insane. So Einstein's up there warping time and space, and we're down here just trying to get directions.
Right. It's amazing how relevant his work still is. But it goes beyond technology, I think. It's the way he thought that we should be trying to emulate. Questioning, challenging, always pushing for deeper understanding.
Absolutely. So as we wrap up our Einstein deep dive, what would he be challenging today, I wonder? What truth would he be telling us to look at in a new light? That's something to think about. Thanks for joining us.
Thanks.